Hello, my dear friends. Before we start implementing the movements, I would like to address two things. First thing is that our dice, these are very nice, and we can animate them based on the click. But there is a problem with this one. This one is transparent and it shows the top layer, but it also shows the bottom layer due to its transparency. And sometimes it's not clear which number is on the top of the dice, and I don't want people to fight over it. So I'm going to fix that. So for that, I would let's go back to our code and let's see. Okay, so we just need to, we already have the information. We need to fix that. We have the role. So when we are setting the dice, we can set that side of the dice, which would be the top side at that point. We should give it the background color of white. So in order to achieve that, we need another array. So let me quickly add that array. This would basically convert the roles into we are going to get an index of role here. So we would use this index to get the correct class. So, so let's quickly add that here. So also, in order to know that we only want to apply this transform to the transparent dice. So we have to know that if the dice dot ID, dice has an ID and it includes red. So if it doesn't include red, if dice doesn't include red, only then we have to perform this. And what do we want to do? We just want to select the dice dot query and selector, and we need to pass that class. So we would pass this class as this index would correctly give us the side which is on the top, and we would just give it background color as white. So this would make sure that whichever side is on the top should get the background color as white. But we also need to clear this effect. We need to restore the sides uh, before we enter into this function. So we are simply writing that function. So this function would simply restore all the sides back to their original color, which is 0.25, white with opacity of 0.25. So let me show that. Let's try check if this matches with the sites original design. So yes, this is the color that we want. So we are restoring that color, and here when we figure out the dice, we simply would want to run this function. If it doesn't include the red, then it means it's other dice. So in that case, we need to restore the sites. So let's try to quickly see that if this works. So let's share this and let's refresh and let's roll the dice. So as we can see that the top side would always have a white color, and when we roll it again, then all sides are restored, and whatever side would be on the top would get a background color of white. So this is a quick fix. And secondly, I also want to give the credit where it's due. Basically, for 3D dice, I took inspiration from this link. This is a very nice link. I would also give this attach this link in the description. This they have the similar process which we followed. Basically, I took inspiration from them, especially these rotations. They were very nice in teaching me about the 3D dice. So I took inspiration from them, and you can also have a look at it, and you can learn a lot from this resource. So this is a very nice resource, and you can even edit it on CodePen. So this I wanted to give it the credit. And now let's resume and let's figure out how to move our dice. So let's try to implement the movement. Now, based on the dice roll, we should move, our token should move. So for that, first of all, we need some structure. So we need something, we need some helper functions, and we need to organize our gameplay in some sort of structure. So for that, we have these three functions. First of all, we would need these three functions. We have to initialize. This initialize would initialize all the tokens. Then we have to create a path loop, and we have to add final path points. So I would start implementing these functions and start explaining these as well. Initialize the tokens. Basically, we need to initialize the to total tokens in our grid, in our Ludo board, and we need to know where there are, what are their positions, and then we have to create a path loop. Path loop is basically from where a token should start and what is the path for that token to complete and go back finish it on its own. And the final path points are basically uh, for each house, red, green, blue, and yellow. We have to know the final positions where they would be able to move and then finish the game. So I would explain this on actual board as well, what I'm talking about. So first of all, let's try to implement the initialize function. So for initialize function, we need our tokens. So we have to have a tokens array. So let's me define that on the top. And we would need to define our initialize function. So let's write our function initialize. And what do we need? We need all the array. We need all the tokens in our HTML, and we need to uh, give them proper positions and store them in the array. So this is what we are going to do. Let me quickly implement that function. So in this function, first of all, we are getting all the elements which have token. We have 16 elements which have token class. These are all the tokens that we are going to get. Then we have some properties. These properties are needed to give correct positions. So our padding is 75, which we defined in our CSS style as well. Then there is a small gap between each token. So let me quickly show the board so that we make sense of things. So this is our current board, as we can see. So this is suppose the first token in each house. There is a padding of top and left 75%, 75 pixels. Then this token comes, and then from this position to the next position, there is a gap between them, and that gap is of 100 pixel. And this gap is same as this is small gap, horizontal and vertical of 100 pixels. And that is what we are arranging in our JavaScript. Let me quickly go back. So we are giving it a small gap of 100 pixels, and the padding is 75 pixels, and then is a big gap. Big gap is between houses. So let me get back to the browser. If we look at this, then from this position to this position, there is a gap of 450 pixels. These are all have been, these values have been calculated. So I think I know that these work. So we are just giving the offsets for red tokens. Token number one, token number two, token number three, and token number four have these positions. Similarly, for green, yellow, and blue, we are giving them the proper positions. And then we are initializing this array, this for loop. Like we go over the total tokens, which are 16. Then we assign the XY positions based on these offsets for each token. So for red, we would give the red offsets. For green, we would give green. For yellow, we would give yellow offsets, and for blue, we would give blue offsets. Then our token is constructed. We give the position and start position. Start position is important because suppose our token gets hit by another token, so we have to send it back to its start position. So for that, we need this start position. Otherwise, we are storing the current position of the token, and we are currently not assigning any house. We later assign the house based on the token index. Then we know first four tokens are red, then next four are green, next four are blue, and next four are yellow. So we are assigning these tokens, and here we are giving them also for testing purposes. I'm also overriding the right click button. If we right click on any token, then it should send them to home. So we would implement this function as well, send home function. And otherwise, we are pushing the tokens into the token array. So let's implement this send home function as well. It's a very simple function. It would just send any token back to home where it started from. So let's quickly implement this function as well. So here we would have this send home function. It takes in an index. Basically, this index is from the token array. So it knows which token it is. So we just get that token, and we set its current path index to -1. We would know what the path indexes are when we implement this path loop. And then we set its at home property, which is currently being set here. Its at home property is true. Basically, it is back at home. And we set its the HTML elements top and left appropriately based on the start position. And then we have to return false as well because we are overriding this right click function. So this is send home function. Okay, so now we also need to implement this create path loop. So let's quickly implement this path loop function. This might be a bit challenging, but I will explain each and every step. So let me quickly add this function. Okay, so let's define this function here. Okay, so first of all, this is our create path loop. We have the x offset, the distance between each x cell is 50 pixels. Let me quickly show you the screen board. So let's see, this is one cell, and each cell is 50 pixels apart from the other cell in x direction, and similarly in y direction. So we are starting from here. So for this, x offset is 50. We have to have 50 distance from each cell, and y the starting y position is 300. Basically, uh, this is 300 by 300, so this one would be 300. The y position would be 300. So that's why we are giving those starting offsets. Then our cell size is 50. So we know that cell is 50 by 50 as defined in our CSS file. Let me quickly show that to you. So here, if we see that cell is 50 pixels, so then we have this have helper function which adds 6 cells into our path. And so what this does is we need to have a array path loop. So let's define this array. Okay, so here we also need to define a path loop array. So we need to add in this function, we get starting position, start x, start y, and the difference of x and y, what is the rate of change in each step, and the total count, how many cells we want to add. So we need to add 6 cells to the right. So we have our starting x as 0. Our x is starting at 0, and our y is starting at 300, which I showed in the board. Then we have x offset. This is basically dx. So we are going to only change x 50. The rate of change would only be in x direction, or which would increase it by 50 pixels. Then we don't need to change y, and we need to add 6 cells. So this loop would run for six times and add these 6 cells in our path loop. Then we need to add vertically up cells in section 2. So let me quickly go back and show that. So now we are done with this line. Now we want to add vertically these cells vertically on top of each other, and their order should be correct. So we would start from here and sequentially add these 6. So for that, we would again use our helper function, and we are just giving it starting position of x, and then starting position of y, and we are giving it that x doesn't change. The rate of change is x is 0, and the rate of change of y is negative 50, which is the cell size, and we are adding going to add six elements. Then we have this middle point. Let me show that as well. Then we add just this middle point and next row. Then we add this row, middle point, and so on. This is a pattern we are going to follow, and by following this pattern, we successfully create the path loop. At the end, we just take away the last element, the first element, and put it to the last. What I mean by this is our path loop starts from this cell. So instead of starting from this cell, we are just shifting this cell. We are putting it at the end of the path loop. So our first cell becomes this. Then a whole loop completes, and this one becomes our last element. Now this path loop can be used for all the different house colors. And let me quickly show how it would work. So we also need to add some, we need to have some helping positions. So we need to know that. So first of all, let me add those. Based on our path loop, we have these positions. We have starting positions for each house, and we have the order red, green, yellow, and blue. And we also have house entry positions, at which point during the traveling, we come at the position where we can enter the house. And then we also have safe zone, which are these are those colors which those cells which are colored in their house colors, and these are safe zones. We also call them stops. So we have added those as well. Also, we need to have one more thing. Our path loop function is complete. We have created the path loop. Now we also need to add final path points. These final path points are basically those points where if we uh, if we arrive at our house entry point, then we need to enter our house as well. So for those paths, we are separately creating the arrays. So in order to store those, we have to have four arrays with small paths. So this is final path points for red, green, yellow, and blue. And let me quickly write that function as well, where we need to create those final path points as well. So for that, we would write a similar function that we wrote for our path loop. And let me quickly add that function. And so here we have this path function. So we have a helper function for add final line. But for before we start, we have this cell size of 50, and we create a configuration for paths. So for red, we have this array of final path points red. For green, we have green and yellow and blue and so on. And we are creating these positions from where the entry point is created, and we are also giving which we are also giving the rate of change, which dimension to change for red. We need to change x direction in positive direction. For yellow, we need to change x direction in negative direction, and so on. For green, we need to change y in positive direction, and for blue, we need to change blue in negative direction. Let me show that quickly on the board. So here for red, we need to go in positive direction for only x. For x point. For green, we need to go positive in y direction. For yellow, we need to go negative in x direction, and for blue, we need to go negative in y direction. So this is what we are doing. We are creating these configurations, and then we are just simply sending these parameters to add final line. So we add the final line up to 6, and we give them the proper increment. This is a very similar function to this add line, and it adds correct values in our array, respective array. So this function creates our path points. Now we have successfully created the path loop, and we have also created a mechanism to send token home, we have initialized all the tokens. So now we need to implement the gameplay, a slight gameplay. This is not going to be super accurate. So first, for that, let's remove some confusion. We need to comment out this dice. We would implement multiple dice in the next part. For now, we are going to comment out this dice, and we are going to base our code around this roll dice. And also, we need to add a few more functions in order to make our dice move. So one function that we need is basically we need a select token function. Select token function would actually, after the dice has been rolled, then we need to select which token do we want to move. So for now, we are just going to be playing with the red tokens. So I'm going to quickly add a function on click. Let's call it select token, and let's give it an index. So we already have a token array, so we would give it a index of we would give it an index of 1, 0, 1, 2, and 3. These indexes will make sure that only red tokens are being selected. And let me go back and implement this function. Select token would be a very simple function. We need to First of all, we need some variables where we need to know that our dice has been rolled and not. So before this, let me minimize these functions because they're causing a bit confusion. Okay, so before roll dice, we need to add some variables. So we need to know if dice roll is rolled and if dice roll is expired. So basically, we are trying to implement a mechanism where if the dice has been rolled, only then you can move the token. And if you have moved the token once, then that dice roll should be expired. So that we cannot abuse the dice. Suppose we have got 6 and we start moving all the tokens by 6, and we don't even roll the dice next. So we are implementing this kind of behavior here. So we would just add a few conditions at the start of this dice function. So if dice roll is dice has been rolled, then we need to return. We don't need to roll another time. And then also if dice is not rolled, we set the dice to be true. Then we also need to set this value. Once the dice roll has been finished, we need to set some values. So here we are going to add dice roll false because our dice has been rolled, and dice roll expired is false as well. So this will make sure that our dice roll started at a certain point and ended at a certain point where we are making the correct decisions. And also, um, we need to now add the select token function. So let me quickly add that function here. So select token would select a token based on index. If dice roll has been rolled, then we don't need to select the token. If dice is not rolled, then we return, and then we select the current token and we call the function move token. So let me implement the move token function. Basically, this function would help us to move all the dices. So let's quickly add that function. Let's minimize the functions. Okay, so here we would add move token function. It is going to be a bit complicated, but I would explain each and every step. So we need to implement move token function. Okay, so let's get back and let's see. Okay, so first of all, we have this roll dice function where we roll a dice and we make sure that once the dice has been rolled, then we move the token, and we don't call the move token function from here. We actually wait for the user to select the correct token, and then we move it. So when that token has been selected, it just makes sure that correct token is passed to the move function, and it guards against if there are the dice is not rolled and so on. So basically, in this function, when we arrive here, we see that if dice roll has been expired, then we return. It means that once the dice, once the token has been moved, then it shouldn't move again. We need to roll the dice again. So this is making sure of that. Then we also check that if the token is at home and the roll is less than 6, it means the token was at home and we didn't have yeah, high enough roll because in order for token to come outside the home, we have to roll 6. So if for first and for the first movement, the 6 roll is consumed. So and based on our based on our house, we have different start indexes. So if our by default we have 0, which is for red house, and if our house is green, then we would get the start position which here our start position. So we would get 13, 26, and 39 respectively as the start position for each house. Then we also need to check. Okay, if this condition checks that our dice our token is moving for the first time and we have rolled a 6, so it would just place it on its starting index, and it would return, and it would also set the dice roll to be expired so that we don't abuse the dice. Similarly, if that's not the case, we are already out and we are moving, then we just calculate the length based on the roll. And here we are just checking the total path length, and we are checking the entry points. Basically, for each house, there's a different entry point. So we are just correctly identifying the entry point or also getting the final array. And here we just perform some calculations that if we are near the entry or if we want to enter the house, and what is the count. These conditions are being checked, and these conditions make sure that we enter the home at correct index and at the correct place. Then once we are inside, then we have to use the array which we created here, final positions array, and we need to get the positions from there. This is making sure of that. And once and then we actually animate the path movement. So for that, we are calculating the roll. We are getting the roll passed in. So we just run a loop from step 1 to less than roll, and we just increment our path index. We increment our path index and we animate the token to that path, and we just get the point from that path loop. We just get that point, and then we use points x and y to animate the token from one path to another path. And here we are adding delays in increments of 120 milliseconds. So for each movement, we are moving in s steps. So for each movement, we have to add a delay appropriately. So this is making sure of that. And then after everything is settled, we need to update the token's current path after this movement has been done. So we are giving it another timeout. So this function makes sure that we can move correctly. And so we move based on our movements. And let's check it out if it works. Okay, so we missed one more thing. We have to define a role, a current role in variable. So after we get a role, we have to set this current role, and that's where our select token picks the current role. So we have to pass this, and then we go to this move token function, and it moves our token appropriately. So let's give it a try. Let's go to our Firefox, and let's try to run this. Okay, so first of all, let's refresh, and let's get a row. So we have got 5, and if we can only click on our 4 tokens which are red, because we for these haven't registered this on click event, and when we click on it, nothing happens because we didn't get a 5. So later we would implement some visual cues, so we know that we can't move them. Um, for now, for testing purposes, we don't do that. So let me get a row of six because it's taking too long. Okay, so we have finally gotten a six. So when we click on any of these tokens, it should move here. So let's click on this. Okay, so we have moved here, and now if we click on it again, it doesn't move because we have implemented token expiry, dice expiry. So we have to roll the dice again. So this has resulted in on and so on. So I would pause this and resume when we are at the position where we need to go enter into home. So we have gotten into a situation where we are going to enter our home. We have got rolled out a four. So if we click on this, it should move four steps and inside the home. So it has done that correctly. And then we can see if we are able to move this to the finishing line. And if we click on that, we have successfully moved to the finish line. And let's roll once more. And okay, we have got a six. Then let's roll another. So let's also try to click on it again. So if we click on it again, nothing happens. And if we click on other token, it moves. So the token which can move, so would move. So we have implemented these basic functionality of a dice roll, and we have tied it to the tokens, and we can move the tokens based on our dice roll. So this is it for this part. And one thing that I want to declare here, uh, this implementation of Ludo seems deceptively simple, but it's not. It's a very complicated process, and we have to take care of a lot of borderline cases, and the logics are not as simple as they seem. It's easier to describe, but it's difficult to implement. So that's why I have huge respect for many past developers which have created the games for Ludo, especially one game I used to play, which was Ludo Star, and many others. So they deserve huge respect and appreciation because creating a Ludo game is a smooth Ludo game with lots of nice animations is not an easy job. So for our purposes, this video is complete. We have been able to implement the movement, and we have been able to tie it to the dice. In the next part, we would see how we can chain different dices. For example, we get six and five, then we need to store that information and we need to move the dice. Then we would also need to implement this hitting the token from one token can send other token home, this kind of functionality, and so on. And also, as we saw that we have implemented this send home functionality on right clicking. So if we right click on this, it would send it back to home. So this is also been implemented. This function would help us in creating that effect where we hit one token with another and it sends back to home. So this kind of functionality we have added, and in the next part we would further enhance this functionality, and hopefully I would be back soon. Thank you so much for watching, and please share your thoughts. And if you like this, please subscribe and have a nice day. Thank you.